Hi, and welcome to Team Ultimate Amoeba's presentation. Our group members were Shorya Singh, Sharon Ravi Gopal, Rosemary Blair, Veselin Grancharov, John Jarrett, and myself, Andrew Loftus. The cognitive task that we designed for ourselves was to select a restaurant based on many criteria. Some of these criteria were hard limits, such as need for parking or price range. Others are more preference-based, such as speed of service, atmosphere, or food quality. Here are our initial hypotheses and the corresponding nulls. Our first hypothesis was that the range of factors considered in selecting a restaurant would significantly vary in importance from person to person. Second, as students, we naturally predicted that the most important considerations would be price and distance. Finally, we hypothesized that the traits and lifestyle of the person would influence the selection process heavily. In other words, we predicted that the cognitive selection process was not objectively or solely based on factors pertaining to the restaurant, but also was influenced by the demographics of the individual. These factors are external to the restaurant, but are still very important. The key finding had to do primarily with how emotional states influenced the restaurant selection process. As shown in these selected quotes from interviews, mental state and emotional associations are multifaceted in their effects. Oftentimes, more logical factors, such as dietary concerns, got thrown out when emotion is overpowering. Very powerful associations can be made through strong emotion. These create connotations with different cuisines and other factors when considering where to eat. Finally, emotional flags or associations can help to drive the initial ideation of which restaurant to go to, helping to unconsciously or even consciously have ideas pop into one's head. Many literature reviews supported several key factors in the restaurant selection task. The factors that were the most common were price, distance, food quality, reviews, speed of service, crowdedness, cuisine type, whether or not it was a first visit, and atmosphere. These factors represent many other considerations. Food quality, for example, is inclusive of taste, temperature, and presentation. Atmosphere involves the comfort, ambiance, courtesy of waitstaff, and appearance. The importance of these factors change over time as well. Restaurant reviews are a great example of this, as they matter more when the restaurant has not been visited by the subject yet, but lose their significance once someone has had first-hand experience. These studies reported great variance across different demographics, indicating good support for our third hypothesis. Our second hypothesis was supported by several studies, in that price plays a large role for students. It was seen that it also increases in importance for people during their retirement. A very interesting piece of research that is heavily represented in our model indicated that oftentimes factors are nonlinear. For example, the quality of food more predominantly serves to hurt a restaurant if it is poor, but good food is generally considered good enough, and there is little relative benefit once a certain level is reached. The inverse was true for atmospherics and quality of service, both of which were found to have had a greater positive effect than negative effect, even on a distribution centered at zero. Food quality also pulled very strongly. Our interviews further solidified hypothesis 2, with many students appealing to monetary restrictions before anything else. Distance was the second highest answer, supporting the other aspect of hypothesis 2 as well. Finally, despite the large number of responses for reviews, many expressed a sentiment similar to that in the literature. First-hand experience trumps reviews. For our implementation, the first concern was about data. What kind of factors did we need to represent, and how would we represent them? To this end, there were three main categories of variables, with other, just as important, but more specific data types floating around as well. First, hard checks prevent a restaurant from being considered if they are not met. The price range specified by the subject is non-negotiable, and availability of on-site parking is sometimes necessitated based on randomized or manual feedback. Naturally, these are all categorical and essentially come down to Boolean operations, or in other words, cognitive effort in the form of logic. Soft checks are the heart of the preference encoding process. These are all factors that matter to varying degrees for different individuals, as supported by our interviews and literature reviews. These are bounded from -3 to 3 and are initialized to 0, save for a few. Some safe assumptions can be made, say for a fast food restaurant, that they will have at least 1 for speed. The -3 to 3 scale, however, works on a core metaphor in that the negative values represent below average and vice versa for positive values. For every iteration on a restaurant, these values are updated and learned. As the subject visits the restaurant more, these values converge towards the truth value. In regards to calculation, every previous value is stored, and a complex, infinitely weighted equation considers the derivative of the discrete points, as well as performing nonlinear transformations with ramp functions, implementing both emotional effects on strength and hindsight perception of memory, as well as the nonlinearities in various factors due to the good enough thinking mentioned earlier. Emotional apathies are bounded values from 0 to 100 that represent how much an individual cares about a soft check. These apathetic values are also learned. For example, if a restaurant is liked overall but had a terrible rating for cleanliness, that implicates the apathy value in a way that suggests that it should be low, if not already low. The bias of the soft check is then weighted by the squared and then renormalized apathy values, which preserves the strongest factors but minimizes weaker ones as a form of emotional focus. The actual structure of the system is somewhat unique. The cognitive agent is actually made up of two parts that communicate imperfectly and interface with the outside world. The executive agent is actually making the decision of what restaurant to go to based on its own copy of biases and apathies and hands that off to the simulated subject, which gives feedback on the result of that visit. Finally, there exist truth values for the restaurant soft check values, such as an objective rating for the cleanliness of the location. This simulated subject then creates feedback through imperfect and randomly offset samples of the truth values. Previous memories associated with the restaurant also factor into this feedback, as well as emotions. Strong emotions will polarize the random offsets as well as increase their magnitude, adding entropy to the system. Both halves of the cognitive agent have their own sets of local variables, which attempt to converge through the learning process. The actual executive agent takes in data from the environment, memory, and emotional states to pull one restaurant at a time. How the signal restaurant is pulled is very complex, relying on emotional memories and apathy values predominantly. If you just had one great experience at a southern restaurant, the system will likely look to pull another southern restaurant in the next iteration, as you'll see in the demo, if not already overpowered by another factor. The individual restaurant is then elevated to be evaluated one more time in a bucketing fashion, or in other words, good enough fashion, with very intricate processes creating a new order of checks every single time. If the restaurant is eliminated, the pull method also now takes into account why it was eliminated and will seek to only pull restaurants which won't get eliminated in a similar fashion. This also changes the order in which the factors are checked. As restaurants continue to be denied and more are pulled, with more and more constraining the factors, frustration builds in the subject before the subject refuses to pull more restaurants. It makes a parallel comparison between the two best seen so far. This frustration will be recorded and does affect the memory of the experience for future use. The emotional model we decided on was the circumplex model by Russell. This model is fitting as the two axes have predictable interactions with various factors being analyzed and partially supported by the interviews and more heavily supported by literature reviews. It is a Cartesian coordinate pair of valence and arousal, which is kept for records while operations are done with a symbolic conversion to polar and then to categorical units. These categorical emotions are stored in classes and enums as buckets for the values to fall into. The emotional state is affected by the process, with the example last slide regarding frustration as one modality, as well as random changes each iteration. These emotional values massively affect collection of memories as well as the recollection of memories and the innate structure of the system. One of the more interesting ways it interacts with the system is by removing entire portions of cognitive factors depending on mood. More drastic unexpected changes can be expected as arousal increases, with the polarity of the biasing being informed by valence. Now on to the demo. This is what the restaurant selector looks like when you run it. It has a GUI, albeit a very Spartan one, to be able to set the bias parameters if you so desire at the beginning. This will change how the artificial subject gives feedback to the executive agent, which is tasked with learning these biases. In this case, we will go with random, which auto-generates biases and takes you to the first restaurant suggestion. Here we can see which restaurant was selected with some brief detail, as well as a listing of all major factors that contributed positively to the selection of this restaurant. It also addresses any emotional states that fundamentally changed the decision-making process. Now you can click on Next to get another iteration in time. Here you can see that it used the success of the previous restaurant to suggest another southern restaurant. This time, we have slightly different factors that contributed positively. Finally, I can quit so we can look at some data from the simulations. The results support that the two halves of the cognitive agent are following each other well, with an overall coefficient for soft checks and apathies showing convergence on the left, with the dotted lines as averages. The right-hand side shows one example of a particularly variable apathy rating that took quite some time to converge to the constant apathy of the subject. While the convergence could occur sooner in both and with less variation, these are successful results considering there are many additions of random coefficients throughout the process. All three of our initial hypotheses received good support from the interviews and literature reviews alike, showcasing how factors in the restaurant task are highly personalized, including dependence on demographics. The specific demographic of college students was shown to care predominantly about cost and distance. During the project, the model took a drastic shift from an idealistic, heavily computational model to involving more bucketing and semantic labeling, tying back to the idea that due to bounded rationality, efficient pathways have developed that strive for satisfactory but not optimal results. Furthermore, emotions can be specifically examined as one source of these short-circuit pathways that lead to focusing on some factors while throwing out others. and more intricately weighing previous memories in a way that's transformative to the algorithm itself. However, the emotional representations are still very limited, especially when it comes to creating the next state of emotion, which is majorly random at the moment. In addition, the model still fails to converge for some restaurants if not given sufficient visits, or with particularly exotic initial biases. All in all, this project showcased a realistic implementation of approaching a complex task with bounded rationality and parallel computation, memory, and imperfect communication through methods such as emotions.